5.3, rhombuses, rectangles, and squares. In Unit 5, polygons.
Hi, welcome to Math Antics. In this video, we're going to learn about special kinds of polygons called quadrilaterals. Quadrilateral is just a fancy math word for a polygon that has exactly 4 sides and 4 angles, like this one. You should recognize this shape, of course. It's a square. And a square is a special kind of quadrilateral. It's a quadrilateral because it has 4 sides. And it's special because all 4 of those sides are exactly the same length. And all 4 of its angles are exactly the same size. In fact, they're all right angles. Notice also that a square is formed by 2 pairs of parallel sides. These 2 opposite sides are parallel, and these 2 opposite sides are parallel. We'll see why that's important in a few minutes. Okay, so squares are an important type of quadrilateral, but we're going to make some changes to the square to see what other types of quadrilaterals there are. The 2 things that we can change are the sides and the angles. Let's start by changing the sides. Let's stretch our square in one direction so that one pair of sides is now longer than the other pair. This is what we call a rectangle. A rectangle is a quadrilateral that still has 4 equal angles. Notice that when we stretch the square, the angles didn't change at all. But it does not have 4 equal sides. Again, notice that just like a square, a rectangle is made from 2 pairs of parallel sides. All right, so that's a rectangle. But going back to our square, what if instead of changing the sides, we had just changed the angles, like this? What we have now is called a rhombus. A rhombus is a quadrilateral that still has 4 equal sides, but it does not have 4 equal angles. And once again, just like the square and rectangle, the rhombus is made from 2 pairs of parallel sides. Okay, going back once more to our square. What if we try changing both the sides and the angles? Here's what we end up with, and we call it a parallelogram. It's called a parallelogram because even though its sides are not all equal and its angles are not all equal, it's still made from 2 pairs of parallel sides. Get it? Parallelogram. Now wait a second. If that's the definition of a parallelogram, a quadrilateral that's made from 2 pairs of parallel sides, then wouldn't all these other shapes be parallelograms too? Exactly. All of these shapes are parallelograms, just like they're all quadrilaterals. It's just that we have special names for them if their angles are all equal, a rectangle, or if their sides are all equal, a rhombus, or if both their sides and their angles are all equal, a square.
In this lesson, we will learn about 3 special types of parallelograms: rhombuses, rectangles, and squares. As he just mentioned, a rhombus is a parallelogram with 4 equal sides. We call it equilateral. A rectangle is a parallelogram with 4 right angles or 4 equal angles called equiangular. If your quadrilateral is equilateral, all the sides are the same, and equiangular, all the angles are the same, then we call that a square. A quadrilateral is a rhombus if and only if it has 4 congruent sides. If and only if statements mean that if I tell you something is a rhombus, then it must be true that it has 4 congruent sides. But also, if I tell you that it has 4 congruent sides, it must be a rhombus. It's a statement that can be said with the first part first or the second part first. A quadrilateral is a rectangle if and only if it has 4 right angles. If a quadrilateral has 4 right angles, it must be a rectangle. A quadrilateral is a square if and only if it is a rhombus and a rectangle, meaning all the angles are the same and all the sides are the same. Remember, this is an if and only if statement, so if I tell you that a figure is a rhombus and a rectangle, then it must also be a square. The Venn diagram below illustrates some important relationships among parallelograms, rhombuses, rectangles, and squares. For example, you can see that a square is a rhombus because it is a parallelogram with 4 congruent sides. Because it has 4 right angles, a square is also a rectangle. Therefore, if it is a square, it is always a rectangle. But if it is a rectangle, it is not always a square. If it is a square, it is always a rhombus. But if it is a rhombus, it is not always a square. For any rhombus Q, R, S, T, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. Angle Q is congruent to angle S. Angle Q is congruent to angle S. For any rhombus QRST, decide whether the statement is always or sometimes true. If I think about drawing a figure QRST, Q and S would be opposite from each other. In order to make Q and S congruent to each other, then we know that it must be a parallelogram because opposite angles are always congruent in a parallelogram. And a parallelogram means, that a rhombus is a parallelogram. So this has to always be true. Meaning your opposite angles will always be congruent. Angle Q and angle R. Can angle Q and angle R be congruent to each other? It appears in this rhombus that they are not congruent to each other, but could they sometimes be congruent to each other? I hope you're imagining pushing this side up and making 2 right angles. If a rhombus is a square, all 4 angles are congruent. Therefore, these 2 consecutive angles, Q and R, are congruent. Therefore, this is sometimes true, meaning sometimes it's not true, as you can see in this first figure, and sometimes it is true, as you can see in this second figure. Classify the special quadrilateral and explain your reasoning. All 4 sides are the same length. Is it a rhombus, a rectangle, a square? I think you can pretty quickly eliminate rectangle since all 4 sides are the same length. And I hope you're also eliminating a square as the angle measure is 70 and not 90. The quadrilateral has 4 congruent sides. One of its angles is not a right angle, so the rhombus is not also a square. By the rhombus corollary, the quadrilateral is a rhombus. Let's look at the properties of the diagonals. Remember, a diagonal is a line that connects vertex to vertex through the figure. A parallelogram is a rhombus if and only if its diagonals are perpendicular. This tells us that in a rhombus, in a figure where all 4 sides are congruent, the diagonals will meet at a 90-degree angle. This is an if and only if statement. That means if I give you a picture with the diagonals drawn with a right angle drawn, you can assume it is a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. That means that this diagonal will cut this angle in half. It will also cut this angle in half. If this angle is 100 degrees, it splits it into 50 and 50. Same with this diagonal and the angles D and B. If this angle were 80, this would be 40 and 40. All rhombuses will have a diagonal that bisect each other and bisect the angles. A parallelogram is a rectangle if and only if its diagonals are congruent. In a rectangle, the diagonals will bisect each other, just like in any parallelogram. But in a rectangle, they will also be exactly the same measurement. So if diagonal AC is 10 units long, diagonal DB must also be 10 units long. Sketch a rectangle, ABCD, and list everything you know about it. Go ahead, take a minute, pause the video. I hope you drew a picture that looks something like this. If your letters are in a different order, it's no big deal. I hope when you drew your picture, you thought these things. The figure must be a parallelogram, meaning if I were to extend these sides, they could never touch each other. The figure must have 4 right angles, meaning they should meet at 90 degrees. Because it is a parallelogram, I hope you also thought about these things. The opposite sides have to be parallel and have to be congruent. The opposite angles have to be congruent. And the consecutive angles have to add up to 180 degrees or be supplementary to each other. Remember, everything that was true in the last lesson must also be true in this lesson. The diagonals bisect each other. DB would bisect AC. But not only would they bisect each other, they would also be congruent. DB would be equal to AC. That's a lot of stuff that has to be true about one figure. You're building a frame for a window. The window will be installed in the opening shown in the diagram. Part A. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it's a rectangle? The measurements I see are 44 and 44 on the long sides, 33 and 33 on the short sides. So it is true that the opposite sides are congruent, like you would need in a rectangle. But they must also be parallel and meet at 90-degree angles. And we don't have any confirmation of that. So no, you cannot. While the boards opposite are the same length, they form a parallelogram, you don't know anything about the angles being right angles. Part B. You measure the diagonals of the opening. The diagonals measure 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? So you want to remember that in a rectangle, you should have diagonals that are the exact same measurement. So the fact that they don't have the exact same measurement tells us that this cannot be a rectangle. Classify the special quadrilateral. Explain your reasoning. Then find the values of x and y. I see a quadrilateral PQRS. PQRS has 4 right angles, meaning it's a rectangle or a square. PQRS have perpendicular diagonals, meaning the diagonals meet at 90 degrees. This tells us it has to be a rhombus. The fact that it has to be a rhombus narrows down the fact that it'd be a rectangle or a square, because rectangles are not rhombuses. This tells us that it is a rhombus with 4 right angles, which we would call a square. Let's solve for y. In a square, the diagonals bisect each other. Look where y is. Y is on this portion of the diagonal PR. The second half of that diagonal is 10. Because the diagonals must bisect each other, this tells us that 2y has to be equal to 10. They have to be the same length. 2 times what is 10? You're right, 2 times 5. Let's solve for x now. In a square, diagonals don't just bisect each other, but they also bisect an angle. Meaning, all 4 of these have to be 45 degrees. You can also think about the z we created with alternate interior angles, telling us that 5x has to equal 3x plus 18. Subtract 3x, 2x is 18, so x has to be 9 because 2 times 9 is 18. Time to practice. Once you have finished practicing, there is an assignment that follows.